This is a wiper motor I'm using. I'll put some details on the video, yeah, in the description below. Mazda RX-8. I'm sorry, is my... I need to lock off this. Need to lock off the tripod here. Sorry about that. Front windscreen motor. And see how I've got like bigger holes in here for the heads. Phillips, so that you can get Phillips in there and tighten them up. And there's a nut, like almost like well, it is a captive nut, I suppose. And each of these bolt goes up into there. There's like pegs on these as well, like lining up pegs up. These security pegs. These are very powerful. Now there's quite a few, I think, similar sort of fitting on the end, although they mightn't. I looked for one that had a nut fastening on. I don't think they all do, but they almost have these splines. Well, there are splines. Not focus, just a second. Yeah, can you see those splines there? But it almost curves narrower. Right, so the shape of the cog has to be similar to that. Now this is a very tight fit indeed when it's built, and you have to see that won't even go on there really. Well, it'll go on there a bit. See the nut there? There's a bit of roughness on here because I've had supports on here. I need to maybe adjust the supports. But what you do then is basically, well, I've got like a locking washer. Pop that down. Can I get that on it? I think there's like bits of loose plastic filament. Just some hairline, almost like stringing, I think, or something. Just scraping it with my nail here. And let's try that again. Pop the nut on, got that balanced on. Now be careful this doesn't cross thread. A socket set, I've tried to leave a gap on there. It should be enough for a socket to get in there. But I'm going to try these long nose pliers, just get tightened up a bit. And basically what you do then is just keep on tightening it, and that will force, this to push on to the spline shaft, and the plastic will deform a bit. I'll show you that when I've done this. You can't really turn this because the whole thing will probably turn. While I was trying these long nose pliers, I mean they got it on quite far there, but I'll have to get a socket set into here. And a socket into there to tighten it up. Okay, get the light on there, so you can see that has moved down. There's still some bit of spline showing there. Don't know if I can make that out. So it needs to tighten up a bit more, but you get the basic idea there. I'll put some, well, I'll show you a picture of the wiring. basically there's, in a way, well, I would say, yeah, there's two wires. There's like neutral and 12 volts either here or the pin in the top right hand corner. So that's low speed, the top right hand corner. This is high speed, bottom right hand corner. That is like pins there. The other ones are basically switches. Well, a switch, I think it's a two-way switch. Look at the wiring diagram here. And that's like for the park, because on a windscreen might be, when you turn it off, you don't want the blade to stop halfway, because it's going to be, it's going to distract you, even though it's stopped. So it continues on until it gets to what is known as a park position for the windscreen wiper at the park. And that's what the switches are basically for. You have a look around here. These are worm gears. I mean, the motors are powerful, but going through the worm gear gives it an awful, quite a lot of torque. So that should be enough torque for the shredder I'm trying to put together here. I'll tighten that up. I'll probably get this like on the board. See, this is for belt drive. I have to see how well the belt drive does. If it slips, I'll have to do some sort of gearing, I think. So you've got some adjustment there, and on the other part you've got the adjustment the other way. Okay, there's a bit of a look round. I think this is like a shock absorber thing. It must clamp in somewhere. And that's used. Permanent magnet, this one. I don't know if you can get electromagnets. Now be careful if you get this thing, it will only suit this particular wiper, because they're all different fittings, well, nearly all different fittings for the mountains and such like. So that's one problem, is, you know, there's no like uniformity. This front wiper. And it's got some embossed numbers or letters on there for the three on that side and 2 on that side, so to indicate, I think, the wiring. Right, I'll come back when I get this completed. Well, right, I've done a basic setup. There are some other attachments that like bolts. You see these blocks here, I might just make out that block there, you can push against there and that will tighten the belt up, and then you can tighten them up. This is pretty damn tight actually. I'll turn it on now. 12 volts. This is a windscreen wiper motor. These have a lot of torque, a lot of power. You haven't tried cutting anything with this. Bit muck on there. That's just like a safety plate. But I'll turn it on now. 12 volts. See, and it does turn. Okay, let's take that safety plate off now. I have to be careful. Here's something I was working on earlier in my other video about trying to do this. This is a cutting blade disc, metal. One problem with windscreen wiper motors, all the mounts are different. So I made a mount for this one. It's a Mazda RX-8 2002-2007 front windscreen wiper motor. I'll put some details here. and I'll put a drawing again of the wiring. Now you can, in this case, on this wiper motor, you can swap the wires over so it will turn the other way. But you have to be careful of that, because I did see online that somebody was talking and they have a switch inside, what they call, it's like a park switch. So when you stop the when you tell a wiper to stop moving, pretend this is a wiper in your car, it continues on until it's in what they call a park position by a switching mechanism that's actually inside, well, on the disc of the worm gear, if you get me. Now I did see someone mention a wiper motor. This one isn't like that. That has almost a bumped cam, and the bump on one side is like sharper than on the other. So on that one, it's basically you can only, well, you could force it, but probably break the switch. This isn't using the park switch at all. It's just using the power connections. That could damage it, because as the switch, as the sort of cam, raised cam thing comes round and goes to knock the switch, it can't get past, because one edge is a lot sharper than the other edge, which is like a trailing edge. It's alright going that way, because waffle. Right, I'm going to try this. As I say, I tried this earlier. Have a look at my other video with other motors. This is the first time I tried cutting on this, and I'm procrastinating because I'm really worried about doing this. Let's go for it. I've put this bowl underneath to catch any bits of plastic that come off. That is empty, that bowl. Take my word for it. Right, turn it on. Let's go for it. Yep. Have to be very careful here. I think it is cutting there. Let me try and get a flat bit that hasn't been cut, so to speak, so we can tell better. Like this one, can't even remember what this was for. PLA this. This is quite thin, so the plastic is bending. It doesn't make that much impression, but the motor isn't stopping, isn't stalling. Now, let me be very careful. These cutters are designed for cutting metal in machine shops, so there shouldn't be any problems with that. Yeah, it's doing a bit there. I mean, this is just prototyping. I expect I could put more blades on this. That would increase, like make it wider. That would increase the expense. And maybe have another blade going the other way, but that's going to, you know, a bit dodgy. Let me try something thicker, because that's bending. So I've got this about 4 or 5 millimeters thick there. Just checking there to see if I think the belt's slipping. I don't think it is. It's, if you look, it is bulging up there, but I haven't tightened this up just by hand. still cool, that motor. Yeah, we can possibly see that. Oh, it's making a bumpy noise. I think this motor wants lining, well, I think it's slightly askew. Well, I've only just put this together roughly. Now that is definitely stopping the blade moving there. I think this was stretched. Let me stop it a bit. And check that. No, see, it's quite loose there. But as I say, there are bolts you put on here, and like slacken these ones off, and like twist the bolts to push this, because there's quite a lot of tension in the belt, and then tighten those up. I'll do a bit more. Turn it on. I'm only using a 12 volt PSU to power this. I was thinking of actually having more like gears rather than a belt. Let's have a look underneath. Let's see if we've got any plastic at all. And I'll show you, oops, I'll show you under this. So this has been a lot of hacking this. See, lots of holes, and basically got 6mm hex balls, but drilled about a 10mm hole to like countersink them. Yep, we've got some plastic on here. I am faking this, but that's just in that sort of quick trial run there. Now I did have this motor under test by itself. This windscreen wiper motor here, this actual one, it wasn't on the belt, it wasn't connected to anything, only the power, so it was just running freely, and after about 20 minutes, half an hour, it was getting quite warm, the motor, and it wasn't using any sort of torque because it wasn't on there, it wasn't connected to anything mechanically. I'll do a bit more. I'll just show you that under there. See, there's a rough hole cut there for the filament if it does get manked up to come down. Where's my bits of plastic? Let's go back to this one, I think. So I'm going to go back to this one. Either the motor's moved or this has moved. It must have, because it wasn't like clicking like this earlier on. Just let me have a look. I'm going to pause the camera a bit while I can't really, it's hard to figure out where if the noise is coming from this pulley or this pulley. It certainly wants tightening up a bit. Mind you, one problem with the belts is when you do tighten them up, it's taking more torque to turn it. More power. You see there. These cutting blades are meant to take off, you know, 1/10 at a time or something like that, on a milling machine or on a lathe. We'll try. see, you might notice that the wheel was definitely slipping there. Well, as like for professional shredding of PLA in this case, it's not very good, is it? Really, to be honest with you. I think the motor certainly does have the power there. And I can stop this belt slipping, tightening it up or lining this up a bit better, this motor. I hope it's not the gears moved. Let's turn it off a bit. Let's have a look. So you might remember before, trying to knock it down into one corner there. Yeah, I would say it's a bit coarser than washing powder. You know, how long has that took me to like shred that little bit there? Far too long, to be honest with you. Also with more blades it might work better, but that's going to take a lot more expense. These blades that don't come cheap. Slightly lukewarm, not hot, just lukewarm. I don't know if there's anything else I can really show you doing this. So it does work to a fashion. Nowhere near it. Let me try putting this at a different angle actually. I'll try putting it in at more of an angle like this. Just want to listen a bit. Yeah, it's doing this like jumping there. So I don't know what's happened to the, as I say, I think it's come out of line a bit. Well, if I'm holding it like that, it's the blades, you know, almost knocking against it. Here the blades are almost like rubbing over it, so I think it does take less like torque. Generally speaking, this one is supposed to have 2 speeds, but for some reason the low speed isn't working. I think the carbon brush is broken inside. I have 3 carbon brushes. I think 2 are used for the high speed, and they change the brush to come in at a different angle for the low speed. But low speed, this is the fast speed of this wiper motor. I think the motor is powerful enough for that problem is again that the belts are slipping. Listen to that. You see that the whole belt is jumping there. Quite a new belt that. Well, it hasn't been used except on this. Right, I'm going to leave it there. I'm packing it in for now. I might come back and if I bother lining this up, and you know, like another thing is to have the blades almost like come out more. Just the tips of the blades are coming out there. There's a tip, just like the tip, the cutting. So basically there's only about one blade, maybe two, getting round at a time there. That's yeah. This here, this plastic piece here is what I call a wear plate. That you can, well, take the hopper off, change this plate here, which is only about 3mm thick, so it's quite not too long a print. You don't have to print out the whole lot if it's getting worn down, so to speak, whilst it's doing the cutting actions and one thing and another. I mean, overall that's I give it 4 out of 10, so to speak. That's all. So I've got to think about, am I going to like redesign it so that the blades are sticking out more, which would mean to catch the plastic more, but then it's going to take more torque. Or I'll have to decide what I'm going to do, if anything. But it's not put a safety cover on. It's not good enough like for professional shredding. Can you imagine trying to shred that up? I mean, how long have I been and all I've done is that. You know what I mean? It's been a good 10 minutes just to do that little bit. So a big piece like this is going to take, you know, a couple of hours at this rate. Not really practical, not even for hobbyists, I don't think. Is it practical? But sometimes I'm going to try things to see if they do work out or not. Right, I'll just show you that. Try and get that wiper motor in. As I said, these are worm gears. They're pretty powerful electric motor in itself. There's some details. But when it goes through the worm gear, that has a lot of reduction, and that gives it a lot more torque. So I've just got like some tag clips there, so I've got negative on the bottom left and red on the bottom right. That's high speed, and low speed is the top right and one there. The other ones are just switches, but I'll put the wiring diagram on this video. Oops. February 2027, 12 volts, yeah, that's why I'm powering it off. So I'm just trying to give you a bit of a look round. I mean, if I had a smaller diameter pulley here, the problem is that the belt doesn't, it has to be a reasonable sized one for the teeth to sort of grip over a larger area. If you have a smaller one, then the teeth don't grip over such a small area, they're more likely to slip. An advantage with a smaller pulley there would, you'd have like the reduction, further reduction in the speed, but increase in the torque there. Well, I don't know what else I can say. I would class that as a failure.